Hello students, in today's lecture we are going to continue with the back exercise numericals. So 2 we have covered in the previous lecture, this is the third one. I'll read the question. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? I'll read the question again and then we'll just write what is given here. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. So I have written here, given while going to school, Abdul's average speed is, I have denoted it by V1, is equal to 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. For the return trip, that is from school back to home, average speed is V2, I have used the letter V2 here, is 30 km per hour. What is the average speed for Abdul's trip? So average speed for the trip, that is for the entire trip, I have represented it by V and is equal to that. We have to find it out, so question mark is there. Now I have shown here, for you it is not necessary to draw these diagrams. This I have drawn just to explain you that the path can be straight path from home to school. It can be curved like this or it can be like this. It can be any way. Okay, so that is not required here because we are not going to consider displacement or velocity. Okay, now, so while going to school, I hope you have understood why I have drawn this. You will not draw this. This is just to make you understand that the path can be straight, it can be curved, it can be any way. Now, hope you have understood that. Let us assume this diagram. Now, this is A's home and B's school. So when Abdul goes from home to school, his motion must be non-uniform only. But then the average speed which he computed is 20 km per hour. And when he returns back from school to home, when there is less traffic, average speed is more for the return trip, that is 30 km per hour. So one average speed is from A to B, this trip. Second average speed is given from B towards A, B to A, okay. We have to find the average speed for the entire trip. Now when this question is usually given in the class, what students do? They quickly find the answer by just taking the average of 2 and they say the answer is 25 km per hour. My dear students, this is wrong because this is not, see, first motion here, this is non-uniform motion, average speed is given. Second motion is again non-uniform but the average speed is given. We cannot use this formula V1 plus V2 upon 2 for the average speed. Why? Because that is applicable only and only for uniformly accelerated motion and this is not that case. So for this we will just use the basic formula of average speed, that is total distance covered to the, it is a ratio of total distance covered to the total time taken. So we have to divide the total distance covered by total time taken. So let us continue here. Let the distance from home to school be x kilometer because we have to find total distance and total time. So nothing about this distance is given. So we have assumed that let the distance from home to school be x kilometer and let T1 be the time taken to reach school from home and T2 be the time taken to reach home from school. So if T1 is a time for this first trip from A to B and T2 is a time for the return trip from B to A, from school to home, then what will be the total time for the entire trip? T1 plus T2. Okay, but let us first find what is T1 and T2. Now simply using the formula, average speed is distance upon time, that is total distance upon total time. Okay, for each trip we have divided this entire trip into two parts. So what will be time t1? Use that formula. T1, T is S upon average speed. So T1 is S. S is distance travelled. What is the distance travelled from A to B? X kilometer we have assumed. Divided by what is the average speed for this trip from A to B? 20 kilometer per hour. So T1 is X upon 20 hours. Similarly, using the same formula, T is equal to S upon average speed. We can find out T2 is X upon 30 hours. Distance is same in both the cases. Only average speed is different and hence times will be different. Now for the entire trip, because we have to use this formula, we have to find the average speed for the entire trip. For the entire trip, what is the total distance covered? X plus X, that is 2x kilometers. And what will be the total time taken? T1 plus T2. So T is T1 plus T2. X upon 20 plus X upon 30. I have just simplified that, taking the LCM to be 60. So we get 5x upon 60, that is X upon 12 hours. So what is total distance covered? 2x kilometers. What is total time taken? X upon 12 hours. So now we can find the required average speed. Formula once we have written, no need to write the formula again. Total distance 2x. Total time taken, so divided by x by 12. Simplify it, 2x into 12 by x. We have to take the reciprocal. X gets cancelled. 12 twos are 24 kilometer per hour. So this is the required average speed. So be careful students. Don't use a formula V1 plus V2 upon 2 for this. Follow this method, then only you will get marks. Clear? Now the fourth question is, a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square for 8.0 seconds. How far does a boat travel during this time? A motorboat starting from rest. So what is given? Rest. It means initial speed is, when it starts from rest, initial speed is 0 meter per second. Accelerates in a straight line at a constant rate of 3.0 meter per second square. So 3.0 meter per second square, from the units also we can make it out that this is acceleration A. For 8 seconds. So time is 8.0 seconds. How far does it travel? How far does the boat travel during this time? How far means distance travelled. We have to find it out. Now we have read the question twice. We have written what is given, what we have to find out. Next step is to see if any conversion is required. No, everything is in the proper system of units, similar system of units. So let us use the formula now. S is ut plus half at square. Put the value of u 0 into 8 plus half into a is 3 into t square. As I have told, t square means 8 into 8. This is 0 plus 2 ones are 2 fours are 8, and when we multiply we get here 96. So distance travelled is 96 meters. This is a very simple numerical. Hope you have understood this. Now the next question, fifth question is, a driver of a car travelling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 34 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars travelled further after the brakes were applied? So let us read it once again. A driver of a car starting at 52 km per hour. It means, now I have read it once, so I know there are two cars. So given first car, a driver of a car traveling at 52 km per hour. So U1, initial speed is 52 km per hour. Applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Students, we already know that whenever the brakes are applied, acceleration is negative. It is a case of retardation. And here, so the car stops in 5 seconds. It means V1 is final velocity or speed is 0 meter per second. And time taken is 5 seconds. So U1, V1, T1 I have represented for first car. Then another car, in another car, driver applies the brakes. First his speed was 34 km per hour. So for second car, initial speed U2 is 34 km per hour. And then he applies his brakes slowly and stops in 10 seconds. It means stops. It means final speed is V2 is 0 meter per second and time taken T2 for this change in speed is 10 seconds. Now, on the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled further after the brakes were applied? Now in this numerical, they have asked us to draw the graphs. Suppose if they had not asked us to draw the graph, still we could have done this numerical. First, let us see how. So here, this is given for the first driver, that is given for the second driver, second car. We have to draw VT graphs of two cars on the same graph paper and we have to answer to this question, which of the two cars traveled further after the brakes were applied. Obviously for this answer, we should know what is the distance traveled by the first car and distance traveled by the second car. Whichever distance is greater, we will say that car has traveled further after the brakes were applied. But let us do first this in a different way. If they had not asked us to draw the graph, how would we have proceeded? Let us see. Now from this given, we can find out acceleration by using the simple formula A1 is V1 minus U1 upon T1. Now students, see here conversion. Let us see if any conversion is required. Time is 5 seconds. Speed is 52 km per hour. So for 5 seconds, distance traveled will be in meters, not in kilometers. So better we convert this also into meter per second. And using just multiplying it by 5 by 18, here answer comes out to be 14.4 meter per second. Similarly, initial speed of second car, we can convert it into meter per second and it is 9.4 meter per second. Now, acceleration of first car, V1 minus U1 upon T1. I have just put the value, V1 is 0, U1 is 14.4, so minus 14.4 divided by time is 5 seconds. And when we do the simplification, we get the final answer of A1 as minus 2.88 meter per second square. Minus as expected because it is a case of retardation or negative acceleration. Similarly, we can find out acceleration for the second car or second driver. A2 is equal to V2 minus U2 upon T2 and putting the values of V2, U2 and T2 from the information given, we can get the final answer to be minus 0.94 meter per second square. Both the accelerations are negative because in both the cases brakes are applied and these are the cases of retardation, uniform retardation. Now, using the formula, using the third equation of motion, V1 square is U1 square plus 2A1 S1 and when we put the value of V, U1, A1, remember you have to take A1 negative sign you have to take along with it. And after simplifying this, when we simplify, let us take this second term on the left hand side. It will become positive. And then we can take it in the denominator. We get S1 is equal to 14.4 into 14.4 divided by 2 into 2.88, answer comes out to be 36 meters. Similarly, using the third equation of motion for the second car, we can find out the distance travelled S2 and it comes out to be 47 meter. You can do the calculations on your own and get the same answer. So from here, S1 is 36 meters, S2 is 47 meters, S2 47 is greater than this 36 meter. So S2 is greater than S1 and we can write second car has travelled farther after the brakes were applied. Hope you have understood this, but you cannot attempt the answer in this way because they have asked you to draw the graphs. If they had not asked you the graph to plot the graph, then this was a perfect method. Okay, I have taught you because you can do it just to verify your answer, or even if graphs are not asked, then you can use this method. But in this question, we are going to draw the graphs and use the graphs only to get this answer. So we cannot proceed in this manner. This is also you should know how to do this also by this method also. Now let us draw the VT graphs of two cars on the same graph paper as asked. So to draw the graph, this I have drawn one vertical. On the graph paper you can draw one vertical line and one horizontal line. Let their point of intersection be O, whose coordinates are 0, 0. Label the axis VT graph. So this is time, this is V. Units we have chosen for V in the bracket meter per second and for time seconds. So basic thing first is two axes and label the axis and name the origin. Now you can also write a scale here students, because when you draw the graph you have to see the minimum value, maximum value of each physical quantity which is given here. For example, U1 is 14.4 meter per second and V1 is 0 meter per second. It means on this axis, on velocity axis, you want the reading till 14.4. So you should at least draw this, take the scale so that your reading comes till 16 meter per second. Accordingly, you have to choose a scale. And here I have chosen the scale. I'll write it here afterwards. Just listen. You have to write scale chosen on x-axis, on y-axis. What is the scale on y-axis? 1 centimeter is equal to 2 meter per second. And on x-axis, 1 centimeter is equal to 2 seconds. Why I have chosen here 2 seconds? Because time is 5 and 10. At the most 10 seconds is required. But we should always choose a scale so that you can show 2-3 units, 2-3 values more than this. It means if it is 10 seconds, you should choose a scale so that you can show here 12 or 14 seconds. So I have chosen this scale. So at the topmost corner on the right hand side, you should write the scale. Scale on x-axis, 1 centimeter is 2 seconds, and on y-axis 1 centimeter is 2 meter per second. You can change the scale also according to the size of your graph paper. Okay, so the graph scale should be chosen such that this graph should not come within the smaller area. It should cover at least half or little bit more than half part of the size of your graph paper. I hope you have understood this. You have to plot the velocity axis, time axis, label the axis, choose a scale and do this marking on both the axes. Now let us plot the graph. For the first car, U1 is 14.4 meter per second. U1 means when time is 0. So time is 0 here. So U1 should be 14.4, and then we have 2 centimeter is 16. It means after 14, just take 2 millimeters. Just take 2 divisions. That will be 14.4. Because 1 division will be 0.2 meter per second. 2 divisions 0.4. So 14.4 meter per second, and just name this point as A. Now second point, how will get the second point? Coordinates for the second point will be when time t1 is 5 seconds, what is the final velocity? 0. So what are the coordinates? 5, 0. So time is 5, 4, 6 in between that. This is 5 and this is 5 seconds. What is the speed? 0 meter per second. This speed is now 0 and at 5 seconds. So this is the second point. To draw any graph, straight line graph, we should have at least 2 points. Okay, coordinates of 2 points. So we have coordinate of first point, that is 0, 14.4. Second point is, this is 5, x coordinate is 5 and y coordinate is 0. So I have plotted the second point. I know it is a case of uniform retardation where VT graph is a straight line inclined to time axis. So then I can join these 2 points by using the scale and draw this line. So this is the graph, VT graph for the first car. Similarly, for second car, that is also a case of uniform retardation, and in that case also VT graph is a straight line inclined to time axis. So we should have the coordinates of 2 points. Let the first point be when time is 0, x coordinate is 0, our time is 0. When time is 0, what is the velocity? 9.4 meter per second. So at 0, the speed is 9.4. So this is 8, this is 10. In between we have 9. Just take 2 divisions more, 9.4, and label it as B for convenience. This is 1 point. What is the second point? When time is 10 seconds, velocity is 0 meter per second. So velocity is 0 when time is 10 seconds. Where is time 10 seconds? Here. It means our second point is this, D. Okay. So we have got the coordinates of 2 points in the first case A and C. In the second case, the 2 points we have labeled them as B and D. Okay. And we know it is a straight line graph inclined to time axis. So 2 points I have got. So I can draw a line joining these 2 points and this becomes my VT graph for second car. So on the same graph paper, I have drawn the VT graphs of both the cars. Now the question is, which of the 2 cars traveled farther after the brakes were applied? So in this case, we have to use the graphs and answer to this question. We know that area under VT graph gives us what? Distance traveled. So if we see this triangle, see this first car. This AC is the first graph for the first car. This is a graph, VT graph for the first car. So area under this graph means area of this triangle AOC. Area of this triangle will give us distance travelled by the first car after the brakes were applied. So S1 is area of triangle AOC. Triangle is half into base into height. Its area formula. Half into base is 5. Height is this height OA 14.4. And what is a base? OC, that is 5. So I have directly written half into 5 into 14.4. Answer comes out to be 36 meters. Similarly, to find the area distance covered by the second car, we'll see the graph. This BD is the graph, VT graph for second car. So area under BD, this area, okay, that is the area of triangle BOD, will give us the distance travelled S2 by the second car after the brakes were applied. So in the similar manner, let us find S2, area of triangle BOD, that is half into base into height, half into OD into OB. I have written directly there, half into OD is 10 into OB is 9.4. So after we do the simplification there, answer comes out to be 47 meters. See, these answers you have got are the same which we have done before. But the required method here is by using graphs. So we can see S2 is 47, S1 is 36 and S2 is greater than S1. So the second car has travelled further after the brakes were applied. It has travelled farther after the brakes were applied. Hope you have understood these 3 numericals. And now in the next lecture we shall first understand the solved numericals of the chapter 8 motion given in NCERT textbook before we continue with this back exercise. Hope you are doing well, understanding well. Thank you, students.